In this video, I will be talking about the greatest common factor and the least common multiple problem solving. So for example, we have this problem. Johnson is going to plant 18 coconut trees and 12 mango trees. He would like to plant the trees in rows that all have the same number of trees and are made up of only one type of tree. What is the greatest number of trees Johnson can have in each row? So first is we are going to analyze which one to use. Either it is a greatest common factor or the least common multiple. We will know that by understanding the problem. So let us try to solve this. So let me illustrate to you the problem. We have the coconut trees, and this represents the row for the coconut trees, and we want to know um, how many trees are there for each row, and we don't know how many rows are there. Also for the mango trees, so this represents for the rows of the mango trees, and we're going to make um, rows of these trees, and our target is, again, we are going to know how many trees are there for each of these rows. And there are 18 in all for coconut trees, and there are 12 in all. So we are sure that there are lesser rows for mango trees because it must be the same number of trees for each row, and there are only 12 mango trees in all, so it must be lesser number of rows. And which one are we going to use, the least common multiple or the greatest common factor? So based on the problem, we are after of the biggest divisor that can divide both 18 and 12, so that it will be the same number of trees for both coconut trees and mango trees. And just to inform you, greatest common factor is the same concept with the GCD, which is the greatest common divisor. So if you're looking for the greatest common divisor, just like this, looking for a biggest divisor for both 18 and 12, that means you need to use greatest common factor. Or if you are unsure with the problem and if it involves asking for the greatest number, so probably it is asking you to find the greatest common factor, but it is not always like that. So but just in case you are not sure what to do, then just look at the problem. If it involves greatest, then probably it's greatest common factor. But still, the best way to do is to understand the problem, so you will know what to use. So let's use the continuous division to find the greatest common factor. So we have 18 and 12, and both are even numbers, so it can be divided by 2. So 18 divided by 2 is 9. 12 divided by 2 is 6. So let's continue. 9 and 6 are divisible by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. And so let's have now the greatest common factor. So we're going to multiply those numbers at the left. So 2 times 3, that will be 6. So there are 6 trees in each row. Now let's have another problem. We have your local radio station is having their yearly music player and concert ticket giveaway. For 1 minute, every 8th caller will win a music player, and every 10th caller will win concert tickets. You were just the first caller to win both a music player and concert tickets. What number caller were you? So let us try to understand this problem and identify whether it involves greatest common factor or it involves least common multiple. So the problem is like this. So here's the for the music player and how you will win it. You will be the eighth color. Next will be 16th color. Next will be 24th color because it's gonna be every eighth. And also for the concert ticket. So when you will win the concert ticket, if you are the 10th color, and then after that, if you are the 20th color and the 30th color. Now, since it's given that you have won both music player and the concert ticket, that means both it the time that you have called is must be the same. Uh, it must be simultaneous for both music player and the concert ticket. Now the question is, when did it happen? When did this meet the sequence for 8 and for the 10? And observing the problem, it is actually talking about multiples of 8 and multiples of 10. So this involves least common multiple. And so let's use continuous division. So we have uh, 8 and 10, and we're gonna find the least common multiple of this problem. So 8 and 10 are divisible by 2. So let's divide by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. Now we have 4 and 5, and there's no common number to divide with 4 and 5. Then we can have now the least common multiple, or the LCM. So let's multiply. We have 2 times 4 times 5. So that's how you get the LCM. You multiply the left number and the number at the bottom. So 2, 4, and 5. And the product is 40. So that means you are the 40th color. That's why you get both music player and the concert ticket. So the idea there is you use LCM if it involves multiples. And if you are unsure which one to use, you will know if it involves LCM if it's asking for something about the minimum number or the least number or the smallest number. So if its problem involves like that, probably it's the LCM. Although it's not always in that case, but most of the time, just in case you are unsure. But still, the best way to know which one to use is to understand the problem. Now let's try to solve another problem. We have Leslie is buying buns on patty for the family's burger business. Buns come in packs of 14 and patties come in packs of 12. The store does not sell parts of a pack and she wants the same number of buns as patties. What is the smallest total number of buns that Leslie can purchase? So let's analyze this problem. So let us look at how many buns for each pack and how many patties for each pack. So for bun, one pack will be 14. If there will be two packs, then it's gonna be 28. If there are three packs to buy, then that's gonna be plus 14, which will be 42, and so on. For the patties, there are 12 patties for each pack. If we're gonna buy two, then there are gonna be 12 plus 12 is 24. If we'll buy three packs, then it's gonna be 36 packs, and so on. And Leslie wants to buy such that the number of buns and number of patties must be the same. And that's what we are looking for. When will this be the sequence the same? So observe that it is actually involving multiples of 14 and 12. So that means it's looking for the least common multiple. And so let's use continuous division, or you may use actually listing or prime factorization. So it will be up to you. But for me, I see it like the continuous division is the easiest way to do LCM and or GCF. So let's put 14 and 12 and divide. These are even numbers, so let's divide by 2. 14 divided by 2 is 7. 12 divided by 2 is 6. Then let's find the LCM. So let's multiply all three numbers. We have 2 times 7 times 6. It will be 84. So if we keep on adding uh, packs of buns, then it's going to reach 84, as well as the patties. So we are not sure how many packs are there for bun and patty, but we are sure that at, at some point it will be the same number of buns and patties. So there's gonna be 84 buns and patties, but the problem is asking for the buns, so there will be 84 buns. So let's take another problem. Claude is making an art project. He has two pieces of construction paper. The first piece is 45 centimeters wide, and the second piece is 36 centimeters wide. He wants to cut the paper into strips that are equal in width and are as wide as possible without any leftover. How wide should Claude cut each strip? So let us try to solve this. So let's illustrate the problem. So we have this for 45 centimeters and 36 centimeters. Of course, it must be shorter, but of course, this is not drawn to scale. So our problem is to look for to divide this into strips where it will be the longest, but it must be at equal length. So of course, this involves dividing, and it involves the greatest, and because from the word longest, it can be the greatest, and from the word equal, it means common. So you're looking for the greatest common divisor. So it's looking for the greatest or the biggest number that can divide both 45 and 36. So it involves GCF or greatest common factor. So let's solve this. We have 45 and 36 and we're gonna divide it. So both are divisible by 3. So 45 divided by 3 is 15. 36 divided by 3 is 12. Then let's continue dividing. 15 and 12 are both divisible by 3 again. 15 divided by 3 is 5. 12 divided by 3 is 4. So you're solving for GCF, you just multiply the numbers on the left. So let's get the GCF, which is equal to 3 times 3, that is 9. So the answer is 9 centimeters wide. So let's take another problem. So we have Clint and Roger are playing games at their local arcade. Clint wins 6 tickets from every game, and Roger wins 13 tickets from every game. When they stopped playing games, they had won the same number of total tickets. What is the minimum number of games that Clint could have played? So we actually don't know. So the given is they're both playing game. We don't know what game it is, but we are sure that for every game Clint wins, it's gonna be 6 tickets, and Roger, for every win in his game, it's gonna be 13 tickets. But after playing the game, we don't know how many games they have played, but at the end of their game, they have the same number of tickets. So there are many possible ways to have the same number of tickets, but it is looking for the minimum number of games because there are so many possible number of games. So it's asking for the minimum number of games that Clint could have played. So let us solve this. So to let us illustrate the problem, so Clint will win for every game with 6 tickets, and if you will play another game plus 6 is 12 tickets, and another game plus 6, it will be 18 tickets. For Roger, for the first game, he will get 13 tickets. Another game plus 13 is 26. Another game is 39 tickets. So the problem is asking for the number of games played by Clint. But before you can solve that, you need to know how many tickets are there and where they have the same number of tickets. So problem is asking when this 6 becomes the same as number of uh, multiples of 13. So it involves some multiples of 6 and 13, and we're going to look for the smallest number where they have the same multiple. So in short, it's asking for the least common multiple. So let's use continuous division for this. So we have 6 and 13. Now 6 and 13 doesn't have a common divisor. So what you will do is just multiply them directly. So the LCM is equal to 6 times 13, which is equal to 78 tickets. This means they could have 78 tickets. Of course, there are other possible number of tickets where they will have the same, but we are looking for the smallest possible. And so let's continue solving because it's asking for the number of games played by Clint. It's not asking for the number of tickets. So let's only solve for Clint. So 78 divided by 6 because it's 6 tickets for every game played. So 78 divided by 6 is 13. So this means Clint could have played 13 games. So another problem. Odette is a physical education teacher and has 20 girls and 28 boys in her class. She wants to create teams of the same size, separately for boys and for girls. If Odette creates the greatest number of teams possible, how many boys will be on each team? So let's analyze and solve this problem. So let me illustrate to you the problem. So this is for the 20 girls, and we have this. I represent every girl uh, with a pink box, and for 28 boys, I represent every boy with blue box. And the problem is asking for it involves division of this number of girls and number of boys, where Odette wants to maximize the number of members for every group, and it is not necessarily the same number of girls and number of boys for every group, as long as it is the same within the group of girls and it's the same within the group of boys. Okay, so as you observe, as you analyze the problems, it is something involving the divisor, the biggest divisor for both boys and girls. So it must be involving greatest common factor. So let us use continuous division. We have 20 and 28. So let's divide. And these are even numbers, so let's divide by 2. So 20 divided by 2 is 10. 28 divided by 2 is 14. And these are even numbers, so let's divide this by 2. 10 divided by 2 is 5. 14 divided by 2 is 7. So let's get now the GCF. So this will be equal to 2 times 2, which is 4, or 4 groups. So this means we can create, to maximize the members for girls and boys, we can create 4 groups for girls and 4 groups for boys. But it's not asking, the problem is not asking for how many groups, but it's asking how many members for every group for boys. So let's just solve for boys. There are 28 boys in all, divided by 4 groups. So it will be 7 boys. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button. And also, write the math topics you want to learn in the comment section.